Yeah, let's get started. A little bit background on Uniswap. I don't know if like everyone has on the same page about Uniswap, but what is Uniswap, Alexa?
I can start. This is a great question. So, yeah. So I think that anyone who's been in the industry for more than a couple of days heard about the Uniswap. Basically, it's a DEX, and DEX stands for decentralized exchange, and it's, I would say, the most well-known protocol. And about like it uses IMM, so you have two types of DEXs. You have the order books, where you just match the people who wants to buy and sell, like in really simple terms. And then you have the other type, which is APOL, which are these IMM DEXs, and Uniswap is one of them. So if we talk about the implementation, and yeah, I'm technical guy, so we will not spend that much time talking about business. So it's a set of smart contracts. You have basically the factory, pairs, and couple of proxy contracts. We'll go over most of them. And all of them combined give a users a possibility to, give the shitcoin and get something real, or find some pairs.
I think the biggest innovation with Uniswap was that you could, without an order book, perform this exchange. So you can give it some ETH and then get back your meme coin or whatever it is. So like a fixed value formula. So. Yeah. That was the biggest innovation of it. And like Alexa mentioned, a couple contracts in there that are important. We'll run through how these exactly work in the code. But yeah, like the biggest notion is that you don't need an order book anymore. You can just provide some supply, and then you're able to perform the exchanges based off that. Cool. So yeah, why did we decide to do this project, and why is this our goal?
Let's just say hi to Paul and Sid. I see we have new joiners. So our idea, so we are building NIL, and NIL is the sharded blockchain. It's EVM compatible. It's EVM opcode compatible, meaning that execution is the same. So per shard, you have its own mempool, you have its own EVM machine, you have its own state. But which means that without any issues, you can just take any contracts that exist and move it on a single shard. But you kind of introduce the problem where now the whole system, the state, is now split across multiple shards, and then people need to re-reference. So we had an idea that now when our product is mature enough, we wanted first to test out and see, can we really move the production applications? So the reason why we decided to go with the Uniswap, first of all, it's really well known. So it's not really hard to explain people what Uniswap is. The second, implementation of the Uniswap is relatively simple. It's only the set of couple of smart contracts, and it covers everything we want to show. So within the Uniswap, we can showcase people how to use our native multi-currency protocol. We can also show them what is the difference between sync and async, how to combine the sync and async with tokens, and so on. And at the end, we can even go further and discuss different architectural choices. So how you can split and distribute the load across the multiple shards, or how can you put everything on a single shard and have relatively the same thing as you have in Ethereum. And Uniswap implementation just gave us kind of the full spectrum of showing everything we want. So it's also worth pointing that we are a protocol company, so we didn't want to build the full production Uniswap that we are going to maintain, trying to find liquidity providers, and so on. This was an example project done internally by integration team, and it kind of serves as showcase how to build something. I hope that answered your question.
Yeah, I think it's a really good answer. I think unless anybody has any questions right now, or in any other case, just ask them whenever you think of them. I'm thinking we can start looking at the code. What do you think of it?
I don't have anything against. So I'm curious, you guys, how much are you familiar with the general concept of the Uniswap implementation? Let's try to make this interactive. If no one answers, Dennis, you need to do it in next like 30 seconds.
Let's say I can code, but I have not looked at the Uniswap repo. Yeah, maybe once a year ago, but I don't really remember it very well.
Good, good. So basically how the Uniswap works, the core center of the Uniswap contracts are the pair contracts. You can think about the pair contract as just it holds two currencies. And so basically you have, let's say, for example, the pair, which can be ETH and USDC. The idea is that you have something called liquidity providers. They put money inside this contract. So they put either ETH or USD tokens. So they put the liquidity. And well, why would they do it? So they do that, they stake there, and after some time when they withdraw, they take some fee that they earned. And on the other side, the pair contracts, they have a formula that when you send the money, so one of these two currencies, in well exchange rate that the formula calculates, you get the other back. And that's how you achieve the exchange. So I mentioned a couple minutes ago that there are two core contracts. The one is pair contract and the other is factory. So let me try to share a screen and see will this work. So basically, as I said, in Uniswap, you have the factory contract. The factory contract is nothing else than the factory pattern. So it keeps track of all the tokens, of all the pairs. So you have a list of pairs. Let me just open it here. So you have a list of pairs. The pairs are basically the mappings of, first currency and the other currency. And you can fetch all the pairs. And what you can do, you can create a new pair. This basically means that you set up the token A, you set up the address of the token B, and then basically it deploys the new pair contract, and it just saves it in this map. So the difference compared to Ethereum is that in Ethereum, as everything is a single machine, so all the pair and the factory are on the same execution. In our case, as we have shards, so you can have, everything split across the shards. This is why in our create pair method, you can also set the shard. So when someone wants to deploy the pair, you can pick on what shard you want to do it. We wanted to show that here you can really be flexible with where you're deploying something. And if we go to our deploy pair function, so we can see, let me just scroll here. So here, give me a second. Oh, I have you guys. So can everyone see well, or I need to zoom something, or?
I think the text could be a little larger for me, but
let me see if I can do it. Font, it's probably here.
Yeah.
Prince, font, let's put 30. Oh, didn't work.
Maybe Command plus.
Tried it. It doesn't work. Let's see. Give me a second. General. It's not appearance. Maybe zoom.
Yeah, that's good. That's perfect.
Is it better? Cool. Yeah. So as we said, the biggest change in the factory contract from Ethereum is this part here. So when you want to deploy the contract, and this can show how you can deploy anything in nil, you basically have three things. So the contract address is calculating using three params. The first one is a shard. The second one is the bytecode. And the third one is a salt. So to understand why we need all of these, so the shard is there to point out where something is deployed. So when we started designing our protocol, we had a lot of debates. Now that you have so many shards and so many different execution, how can end user track where something is deployed, right? Because of it, we decided that every contract address will start with 2 first bytes, indicating on what shard something is. So only the contract owner who is deploying the contract needs to care where something is going to be deployed. Everyone else who wants to use it, just use the address same as you would in Ethereum. So you don't need to think, are you sending something on a shard 1, on a shard 2, shard 3? You only have the address. And then when you send the message, external message to the, or external message to our network, basically the network finds on what shard it is. It can route to the right mempool, and then user doesn't need to think about it. So that's why we have a shard. So every contract address starts with a shard, and whoever wants to deploy the contract can decide where something is going to be. Other two are just so we have the randomized other part of the address. So we use the bytecode, meaning that using the bytecode, we can get somewhat everything random. But then comes the question, what if we have two same contracts, which we want to deploy on the same shard? And because of it, we can just specify the random salt. And by having all of this, we can easily deploy any number of the contracts on any shard. So in our case, because our bytecode of the pairs is the same, we have the salt and we have the shard. So when we want to deploy the contract, when we want to deploy the pair contract, we specify the shard. It's just uint. We currently have in DevNet, I think, 5 shards or 4. And then user can specify it. For salt, it can be any random value. And then when you first need to get the code. So using the Uniswap pair, you get the bytecode of it. You calculate the address using, we have this method in our NIL library to help you to calculate the addresses. You just specify shard called code and salt. And then what you can do, you can send the deployment async message to any shard, and it just deploys the contract. So if the shard, what you can do step further, if something is on another shard, you can, if something is on another shard, you use async. If something is on the same shard, you can use in the same way sync, so you don't have a small delay. So, and basically by doing this, we enabled that for the Uniswap, you only need to set one factory contract. And this factory contract can manage, well, at least track and deploy all pairs across all the shards. And I would say that this covers the most functionalities of the factory contract.
So say I was to build a client library that interacts, it would have to ask the factory where the pair address is.
Yes, and this is the same how it works with Ethereum. So you have the mapping, and you have the get token pair method. So you basically just say, I want to know where is the pair for 2 tokens. And the same way as in Ethereum, it returns you the address. Here, it returns the address as well. The same way how in Ethereum, you don't need to care, like it's just there. You don't need to think, is it on a shard 1, shard 2? You need later if you want to do some optimizations. But for now, you get the address, and that's it.
Cool. And And why would I want to put a pair in another shard?
Yes, so this is basically decision that any dApp which is deployed on NIL needs to make. So with having something across multiple shards, what you basically get, let me just open here. So let's say that here we have multiple shards and we have multiple pairs. So let me just increase this a bit. So we have multiple shards and we have multiple pairs across the multiple shards. Now, because each shard, as I said, is a separate execution, it has a separate mempool, you can process the things in parallel. Imagine that you have 2 really high load pools, or basically in any dApp, you have these scenarios where you want to do something in parallel. So now you can do it. You don't need to wait for someone to trade BTC to USDC and you to wait for, like, for example, ETH, if you have pairs across multiple shards. This is just one simple example why you would do it.
Cool.
Should we continue?
Yes. Yeah. How do maybe it's good to talk about how tokens work in NIL.
Yes. Let's do the quick rundown. So we do not advise people to use the ERC20s. ERC20 is just a smart contract, and yes, you can deploy the ERC20 contract on any shard because it's just, the bytecode. But there is a big reason why this is a no-no in sharding. So imagine that like the ERC20 works as a centralized registry. So it's basically just a contract deployed somewhere. Imagine that we have a contract which has a high traction, so many people transfer, approve, do something, and it's on the shard free. Let's say that this is Aleksa token, and it's the most used token in the world. So the issue that here can happen is that because now we have so many different executions, first of all, everyone from outside the shard where the contract is needs to use the async calls. And this can bring many issues because with async calls, you need to transfer the message in the mempool of destination. Then you need to wait here to execute, then it needs to go back. So we have a small latency. And also the mempool on this shard can be completely blocked. Because imagine that everyone starts pinging it, you're creating so many new transactions that needs to go to this shard, and this can introduce the issue. And this is why we really spend a lot of time thinking about how we should implement our multi-currency support. And we decided to do something really similar to how the cash works. So in cash, you have some entity which is printing the money. The same way in nil, any contract can be an owner of the currency, meaning that if you want to create your own currency, you again need to deploy, as we did previously, like in ERC20, the contract, like the owner contract of the currency. So any contract can have only one currency. So you cannot, when you deploy a contract, for example, pair contract, it can only be an owner of one currency. And the ID of this currency is the address of the contract. That's how we just enable that you can have only one. So the owner of the currency can do two things. The first one is the only one who can mint, and it's only one who can burn. Meaning that if I want to mint something, the minting needs to happen here on the contract where we have the currency. The same way, if I want to burn something, someone else needs to send what I need to burn here, and then the contract burns it. So we still have this semi-centralized registry where, well, it's not a registry, but kind of the authorship that only the owner can mint and burn. And also in this contract, we can track the total supply and everything that we need. The difference compared to ERC20 is that ERC20, besides minting, burning, and total supply, also keep track of who is owning how much in the same contract here. In our case is, as I said, the same as cash. So once this is minted, it can be sent to any other smart contract. So for example, I mint 100 my own currency, I send it here. This means that this guy here, this contract, which is pair 4, it owns this much of the currency. And whoever owns the contract, whoever have kind of, you can have many mechanisms how you can set who is the owner and limit what actions. But basically, whoever is the owner of this contract can move this currency freely. This means that our main owner contract here doesn't track who holds what. The money flies as you send it. Once you put the cash in the world, it can be sent all around. But yeah, this is kind of the main difference. I hope that this explained at least a bit.
Yeah, to me it makes sense. I don't know if anybody else in the audience might have a question right now, perhaps. Otherwise, I think we can run through some examples in the Uni repo.
Yeah, there is also a couple of things that I also want to point. So we said that a pair contract is just, the matching. So it has like all the logic of minting, putting the money, and so on. And something about Uniswap V2 that we didn't mention is that whenever liquidity provider stakes the money, so puts the money in one of the pairs, it gets back the liquidity tokens. These pair tokens are per pair. So every pair in Uniswap V2 has its own token, ERC20. And it's tracking, and it's basically used that when you want to get your money back plus the fee, you give these tokens back and you get what you staked plus the fee. So our protocol works really good with this, because in the Uniswap V2 on Ethereum, so when you deploy the pair, with the pair, you also need to deploy one ERC token, one ERC contract. This ERC contract is basically the token for the pair. In our case, as any smart contract can be an owner of the currency, this means that the pair by default has its own currency. So you don't need to deploy something new. You don't need to have more contracts to manage. Everything can be managed inside the protocol when you just deploy the pair. Is that clear?
Makes sense. Yeah.
Then that's cool. So I wanted to go over the repository. So we open source the Uniswap repository. So anyone can go here and just check out the work that we did. Here everything is divided, so we have the contracts. Here you can see all the contracts, how we implemented them. Here we have ignition tasks. So if you want to deploy currency, factory, or the router contracts, you can deploy it using here. We don't put the pair here because pair should only be deployed through the factory, as we explained. And then if you go here in the tasks, here you can see the different directories. So if you want to create your own currency and just mint, send around, and so on, here you have the methods how to do so. We try to keep this as tidy as possible. So along with all the tasks, you have a small, tutorial how to use it and what functionalities exists. Inside the core, we have these how to work with the factory, how to work with pair. Again, you can go here and just see what methods the pair provides and how to use it. But to make the life much easier for anyone who wants to try, we also created these free demos. And these demos can be run really simply. I'll show in a couple seconds. And these demos cover end-to-end everything, from deploying the currencies, minting currencies, deploying factory, creating pair, minting as a liquidity provider, doing the first swap, burning, and so on. And also what I think is really cool, these contracts shows a lot how to build something on NIL. So it covers how to send the async calls. It covers how to send sync calls with tokens, how to work with tokens, how to work with different things, how to work with NIL.js as well. So whoever wants to build something or to try out just NIL, I would say that this repository offers a lot of real-life examples that can come in handy. So also we created here a couple of issues. So as we said, we are not maintaining, this is not a full production solution. Inside the issues, we have a couple of good first tasks. This is for anyone who just wants to play with it and you have no idea where to start. You can just take, for example, one of these. It has a nation what we want to add, and you can just contribute. And I feel it can be a cool way of contributing and trying out the NIL. So
I'm thinking if you're experimenting this for your own project and are willing to try this out, or you're doing it, then do let us know. If you try anything you find interesting, or if you're running into, just reach out to us as well.
Yeah. So to run as I said, to run everything, you need to set .env. So there you just set the RPC, your URL, you set, the private key and so on. And then you just need to do npx hardhat compile. And once you do it, you can just run npx hardhat demo, and it should guide you through everything that we said. So it takes a couple of seconds just to make sure everything is compiled and to start, deploying the contracts. So in a second or two, I think that we will start seeing the contract being deployed. Here it is. So we see that we deployed the factory contract. We deployed the two currencies. These are just the random currencies. So we mock the pair. We create the pair. This pair is combination of these two. It's deployed over the factory contract. we have the first currency ID, the second currency ID. You can see that it matches the addresses where these are deployed. So then we initialize the pair. We started minting the currencies, so we need to create a wallet and put the money so someone can stake, swap, and so on. Yep. So yes, now a user can mint. Once the minting happen, we can check the balances. Yeah, we do the minting, we do the swaps. And yeah, here we do, you know, we see the burning, we see that everything is changed. You can check more logs if you're curious. And at the end, we see that everything is done. And this is how you can just see how everything works.
Cool. Yeah. What do you think, Aleksa? I think we've shown a little bit how everything works.
Yeah.
Wanna wrap it up?
I would like to show a couple more things, just for someone who is designing the architecture on NIL. Couple of points to just, you know, pay attention to. So as we said, NIL offers flexibility. So it offers having everything synchronously. So you can basically put everything on a single shard, and you have the same communication between the contract as you have in other, well, L2s and Ethereum. But it also offers completely other spectrum where you can deploy everything all around, and you only utilize the async calls to, you know, do the cross-shard things. So I just want to show kind of the thinking behind of it. So as we said, if we approach the architecture naively, we can say that we can put everything on random shard. So we can say that our wallet is on a shard 1, our periphery contract is on a shard 2, our pair contract is on a shard 3. And this means that when someone wants to do, for example, the swap, user needs to send external call to a wallet. So this is one mempool. User needs to send async call to periphery. Then periphery needs to send the async call to the pair and back to the wallet. So now, even though this is kind of on one side of the spectrum, you can deploy everything all around, but now you have too many async calls, and too many async calls can slow down the application. On the other side, if you compare it to Ethereum, Ethereum just sends one transaction, and then using sync calls, it acts as periphery, it acts as the pairs, right? So as I said, in what you can do in NIL, you can do the same thing as you have in Ethereum. So you can have the user having the wallet, periphery, and the pair on the same shard, and then you only send the one message, the same as you would in Ethereum. And the whole thing about designing these cross-shard dApps is trying to fine-tune it and find the best thing that brings you scalability, but as well doesn't break kind of, you know, the UX. So for example, in the terms of Uniswap, we can say that factory contract can be deployed anywhere. Factory contract doesn't need to be accessed all the time. It's only used when you want to deploy contracts, check out the addresses, and so on. Then we can put the pair contracts all around, right? We decide what we want to distribute, what needs to be grouped, and so on. And then for the periphery contract, we can put the periphery contract on each shard. This means why we can do it, because periphery contract is just a proxy contract. It doesn't hold any state. It just, you know, do a couple calculations. And this way, we are distributing the load, but as well, we are giving a user with the proper user management to have the speed of having everything synchronously. This means that if user is not too concerned about how long it will take, it can have a wallet on another shard and then send the async to periphery, periphery do the sync, and then just back. But if a user wants to do something that is really time sensitive, it can just have its own wallet on this shard as well, and then do just the sync calls the same as anyone would in Ethereum. And that's kind of just the general overview of how you can think about designing these dApps. And yeah, that's all I think I have to share. Go back.
Yeah, I think for people that are interested to dig further, the repo is a great place to look at, and obviously the docs. And if you are not a part of our developer Telegram group, we have a helpful bot in Telegram that gives you access to the RPC and also can share. I can share a link to the developer cohort group with you. Let me paste that in here. There we go. And yeah, the Telegram group link is a better one. So Telegram. Let me get that real quick. Copy link, and here it is. Great. Okay. Cool. Anything else you'd like to add, Alexa?
Nope. All from my side.
Cool. Any questions? Anybody in the audience? If not, thank you everyone for joining. I hope it was equally informative to everyone as it was for me. And till next time, big hearts as well.
Yeah.
Bye bye.
You guys.
See you all.
Thank you.
Thank you.